A group of people were at a networking meeting. Each person exchanged his or her business card with every other person who was present. A. If there were 16 persons present in the meeting, how many business cards were exchanged? And B. If there were a total of 380 business cards exchanged, how many persons were present at the meeting? So first, we apply POLYA's method of problem solving. So the first step is to understand the problem. Let's first list what we know about the problem. So based on the problem, we can say that exchanging cards always involves two persons with two cards. It means that person A gives a card to person B and person B gives a card to person A. Because of that, there is no repetition of giving of cards. For example, if A already gave to B, it means that B has already given card to A. And if A gave a card already to person C, then it means that person C has already given his or her card to person A. So there will be no repetition of cards. Step 2. Devise a plan. So the method that I use is making a simpler diagram. I started with 2 persons up to 5 persons to determine a pattern of card exchange. The persons are labeled with the letters. The exchange of cards is labeled as the line that connects the 2 letters. These lines show all the possible way of card exchange between each person. Each line is equal to 2 cards exchanged, since like what I said, person A gives a card to person B and person B automatically gives a card to person A because it is an exchange. So with this, for 2 persons, the total number of cards exchanged is 2, since the number of created lines between them is just 1. So for 3 persons, the total number of exchange cards is 6, since the number of the created lines between the 3 persons is 3 lines. So for 4 persons, the total number of cards exchanged is 12, since the total number of created lines between all of them is 6. So for 5 persons, the total number of cards exchanged is 20, since the number of created lines between all of them is equal to 10. 10 times 2 is equal to 20. Because of this pattern, I can say that the cards exchange is represented by the lines of the polygon made up by the number of people. The lines of the polygon, which means its edges, and the diagonals that it can make. So because of this, we can create a formula that consists of the number of edges plus the number of diagonals in the polygon times 2 to calculate the cards exchange. So cards is equal to 2 times the number of sides plus diagonals. So let's get first the formula for diagonals. D is equal to n times quantity n minus 3 all over 2. So for the cards, C is equal to 2 times quantity n plus D, wherein n is the number of people and the D is the diagonals created by this number. So let us simplify the equation. 2 times the sum of n plus n times quantity n minus 3 all over 2 is equal to 2n plus n times quantity n minus 3. So we can still further simplify the equation by getting 2n plus n squared minus 3n. Negative 3n plus 2n is equal to negative n. So C is equal to n squared minus n, or n times quantity n minus 1. So the third step is to execute the plan. Cards is equal to the number of persons times the number of persons minus 1. C is equal to n times n minus 1. So for letter A, if there were 16 persons present in the meeting, how many business cards were exchanged? So n is equal to 16. So C is equal to 16 times 15. 16 times 15 is 240 cards exchanged. So for letter B, if there were a total of 380 business cards exchanged, how many persons were present in the meeting? So C is equal to 380, and we are going to find letter N. So let us substitute the values. 380 is equal to n times n minus 1. So we get 380 is equal to n squared minus n, and by using the quadratic equation, we can determine that n is equal to 20, or n is equal to negative 19. But since we don't have a negative number of persons, we are going to consider 20 as the answer. So let us try to check. 20 times 19 is equal to 380. So the fourth step of POLYA's problem solving method is to review our answers. So let us use the formula that we have created to determine the number of cards exchanged is, in our previous example, 2 to 5 persons. So using our formula, 2 persons yields 2 cards exchange, 3 persons yields 6 cards exchange, 4 persons yields 12 cards exchange, and 5 persons yields 20 cards exchange. So based on that, I think our answer is correct.